All right. So we are doing, I have to find the first page, the mole page. We're talking about moles, which is what I'm dressed up as. So Tiffany got that bonus question. So I should make a note. I even have kind of gloves because it turns out moles have like pink hands. And I tried to do the star mole, but all right.
Brittany did guess at the beginning of class. I don't know if that counts technically too, because she'd guessed before anybody else did.
Oh, before I asked and she wasn't here. We'll see. We'll give Brittany a chance. See if I ask another random question, I'll have Brittany do it. But I'll ponder it, Brittany. I mean, she doesn't have a camera though, so if we all dress up, you guys will have to keep your cameras on when we all dress up. So this page is in a pre-lecture that I posted. I think it's about 30 minutes, and I go through, yeah, this number that is crazy big. And actually on your worksheet, the bonus on your worksheet for Monday is for you to come up with your own analogy of how big that number is. So like one of the ones I used in the video is if you had this many paper clips, that many paper clips goes around our galaxy like 2 trillion times or something almost. This number is huge, 10 to the 23rd power. This is why we did scientific notation review at the beginning of the first week. We're all the way at the second week. We're gonna make it through 2 weeks. All right, and I talk about atomic mass. I'll do a quick review of that when we get to the page. But there we go. So we're going to do math. We're going to do factor label. This is why your worksheet 2 and your study set 2, the purpose was to get to this. This is the whole essence of everything we do. We could just like end the term after today once you know what a mole is, right? We cover a lot in this class, so you're getting your money worth. So if you have 1 mole of gold, periodic table, look, got a nicer one. So that is what this number down here is telling you. That is called the atomic mass. And it means how many grams you have if you have 1 mole. And what that has to do with that number on the other side is that 1 mole of gold is 197 grams. Now, I gave you a choice in the video. I'm giving you the choice now. You can go with 3 sig figs or you can go with 4 sig figs. I find some people like 4, some people like 3, some people like 1 decimal. You have to have, you want to try and have 3, at least 3 or 4. Don't do 6. That's not going to make it better. That's going to make it worse because you're going to get lost in all the numbers. What the mole means is that you have 6.02. Yeah, we should go with 3 because in the video I said 6.022, but in this class we've been doing the 3 sig fig rule. That means you have that many atoms. So that's what a mole means. If you have a mole of anything, you have that many particles. The particles can be oranges, they can be atoms, they can be molecules. All right, so if you had 1 atom of gold, we're going to do this as factor label. We're going to figure out the mass in grams. And so we pull the unit down, atoms, and we're going to go to mole. Now, I always am giggling inside because of comments from previous students. There is an abbreviation for mole, and it is MOL. You don't want to say M because M means meters. You don't want to say MO because that's actually a measurement of hardness. And so it's MOL, or you can write the whole word out, MOLE. So I had a student who actually had a degree in English, and she said, well, why bother abbreviating it? Because all you're losing is 1 letter. And so that's probably why I always take the E off, but you can write MOLE. You get the mole is 1. Avogadro's number goes with the atoms, so 6.02 times 10 to the 23. That's how many atoms are in a mole. And then we bring the mole down, and it's still gold. It's 197 grams. So that's what our setup would look like. The mole is like, so my son Joey and I always take the train across country, and Chicago is the central hub. So if you take the train anywhere in the country, you go through Chicago. It's the same with airplanes, that there tends to be a central hub for different airlines. All right, and you would punch it in, and you get this answer. So we're going to go with 3 sig figs. Periodic table, rounded to 3. I just made the decision for the class. Avogadro's number in this class, we're going to go with 3. That video I made for both my classes, and my other class, we go with 4. So this is a negative 22 in my answer. So what usually is happening now, I'm pausing because I'm hopeful that you guys will have your calculator and you will try these. What happens for a lot of you when you punch it in, you get the 3.27, but the most important part of this is this exponent to the negative 22, which is the itty bittiest teeny weeny yellow polka dotted number there is. When you divide by the 6.02 times 10 to the 23, most of you have to put it in parentheses in your calculator, because you have to divide by the 6.02 and the 10 to the 23rd, the whole number. So when you write it on a piece of paper, just put it in parentheses. So if you're having trouble and you're not getting my exponents, that's up to you if you want to try it today or whatever. So usually I make everybody try it, and I go around and I can see what you're doing on your calculator. But that is usually what it is how you're putting that number in your calculator. And that's why I have these answers here. All right, let's go ahead and go to the next one, and then I'll give you a chance to try them. So fairy dust is about this many micrograms. So 43.2, and you can do the funny U, or you can say MCG are the symbols for microgram, or you can write the whole word. And we're dealing with silver. So silver is AG. Yeah. Gold is more valuable, so it's lower on the periodic table. All right, silver is 107 if we round it, and that would be grams to a mole. Oh, I'm sorry, I missed the step. I'm gonna move that over one. So excited to get to the mole. We have to first, if you have a metric prefix, I said this before, the first thing you have to do is get rid of that metric prefix. So microgram, we have to get to grams. The periodic table is in grams. It's not in milligrams, it's not in micrograms, it's in grams. It's how many grams are in a mole. So using that chart, 1 microgram would be 10 to the negative 6 grams. So then, so the microgram canceled, the gram comes down to the bottom, and we go to moles. Periodic table, the number from the periodic table for silver, I'm sorry, it's 108. It's now these numbers, these lower numbers, we're finally getting to use. The upper numbers are the atomic number, or the number of protons. That's what we just did in the homework today, and the homework last week. All right. And you get to moles, pull the mole down, and you go 6.02. Let me finish this one, then you guys can try on your calculator while I answer Shaylee's question. So, or if you don't have a calculator, run and get it. Go ahead, Shaylee.
Okay, I don't know, I might just be mistaken, but aren't micrograms smaller than regular grams? So what are your second 2 numbers switched? Because wouldn't there be 10 to the negative 6 micrograms in 1 gram? Or am I just getting it mixed up?
There would be 10 to the positive 6. micrograms.
Oh,
per
I see
gram.
what you're saying. Okay, cool. So it's negative. So maybe I just got mixed up. Okay, never mind. Got you. Thank
So
you.
what I'm doing, thank you for asking that, Shaylee, is when I'm going to go with the chart that I gave you in the lab. And I honestly don't care which way you do the conversion. You need to be consistent with how you do your metric conversions, because we do use them quite a bit in this term. And so using the chart, it's 1 microgram is 10 to the minus 6 grams. If you want to do it what she just said, you'd have 1 gram, but then you're not using the chart. It would be 1,000,000 micrograms in a gram, which is how I've taught it. But since we're in this environment, all the charts are made with the negative exponent. So I'm going with that. All right, this time Avogadro's number is in the numerator. We're going to be multiplying by it. So we're going to end up with a very large exponent, 10 to the 17th power. 3 sig figs, periodic table has 3, Avogadro's number has 3. We started with 3. In the previous one, we divided by Avogadro's number, so we got a really tiny exponent. So that's something you can judge, because the answers, the exponent is actually extremely important. And so be aware of that on your calculator. It's going to say it all the way over to the right side, and it will say a capital E and then a number. So round to 3 digits and then times 10 to the negative 22. Going back to this one, if you could actually get an atom of gold, 1 atom, that's how small it would be, like infinitesimally small. So in a spot, if you even just had a fleck of gold, there's like 1 billion atoms of gold in there. So atoms are really tiny, itty bitty. It's a question if they're even real. And then now we have stuff inside of them, the subatomic particles. And so you might laugh at my fairy dust, but all this stuff with atoms seems to be a fairy tale. One of the things that's nice about these problems, there's usually just one piece of information. So we're going to start 3.14159. It does have an exponent, so make sure you have that there. And this word molecules does not get abbreviated. Mole gets abbreviated, but molecules does not. If you abbreviate molecules because you decide to have your own clever way, you end up getting it wrong every time for some reason. So I used to have an abbreviation for it, and students would get it wrong. And when I started a couple years ago just saying write the whole word out, it takes you 2 more seconds to write the whole word out. People got it right. So, all right, so we start there. Now we're going to bring molecules down and change it to a mole. So for our purposes, Avogadro's number is going to go with the molecule or the word atom. That's really the key. Mole gets the number 1. Mole is always going to be a whole number. And right now it's going to be a 1. Yeah, on this page it's going to be a 1 for all of them. Nope, there's going to be one where we get to do an extra step. So we're at mole. We pull the mole down, and we're going to go to grams. And then I wanted micrograms. This is back to your question, Shaylee. Might be able to see it better this time. The chart, I always put the 1 with the prefix, so micro, and that chart that we talked about last week, then the 10 to the minus 6 would go with the grams. Again, you can do 1,000,000 micrograms, and that would go on top here. All right, so this step is the step we have to do to change our grams to moles. And we have a chemical compound. Yeah, you won't be able to see me on the board. All right, so this is what I was trying to show in the pre-video because I had a board. So we have 27 carbons, 46 hydrogens, and just 1 oxygen. And again, I always put an X through my oxygen so you don't It was a trick a student showed me many years ago. So you don't think it's a 0. So you don't think this is a 10. Yeah. All right. That's really weird. Oh, I know. I have my glove on. Sorry, somebody just came. All right, now we're going to get these numbers from the periodic table. So you would find carbon. A classroom and lots of space is so much more fun. And again, we're just going to round to 3 sig figs. Keep it simple. So we multiply by the 12.0. This is grams per mole would be a unit put on it. I'm going to work this one out, and then I'm going to comment on that. The hydrogen, you can just say 1.0, and the oxygen is 16.0. So the number of each element you have times the number on the periodic table. So the compound said C27H46O. The subscripts tell you how many of each element you have. If there is no subscript, it's a 1. I do not need to see this work. And what I have found in here is about half of you will always show me this work, and about half of you are comfortable with just doing it on your calculator. So we would take the 27 times 12 plus, and so we get 104. And we don't get 104. Sorry, I had another number on there. Let's ignore your teacher again. All right. I knew it had to be more than 104 because this is a pretty large molecule. Maybe not. Maybe it's 104. It's 386. The units from the periodic table are grams per mole. So you can work it out. This is why. So next Wednesday, we're going to do a practice test. We're going to do it all together. Because then the following Monday is the test. I'm just making sure we're prepared, so we're not anxious. You'll want to make sure you have scratch paper, periodic table, calculator. And so the scratch paper can be something that you can work this out on for people who like to work stuff out. The space that I give you is often, some people will work it out over here, but then it ends up taking up more space than they need. But this is always the number from the periodic table, is always how many grams you have per 1 mole. So this is 386 grams in 1 mole. A reminder, when you punch this in, you want to make sure you use parentheses. Some students will just punch across the top, punch across the bottom, then take the top divided by the bottom. Make sure you put it in parentheses when you divide by the denominator, because you're going to have exponents. We started with an exponent. All my exponents end up canceling out at some point, and we get around 20 micrograms, 20.1. 3 sig figs, Avogadro's number is going to limit us. If you use Avogadro's number, we're not going to have more than 3. So there is, the mole again is our center place. You can go between grams and moles. That's the periodic table. That's the atomic mass. It's often called the molar mass because it's the mass of 1 mole. And you can go between moles and atoms or molecules. So for our class, these will be the 2 terms we'll see. And that is when you use Avogadro's number. So there's all these little things like note cards and stuff you'll see online that have it like that. Now, the reason we're doing that is somebody will often ask me, well, why not just combine these 2 steps into one? Why not have Avogadro's number and just go straight to grams? Because we're going to go somewhere else now. From a mole, once you get to moles, we're going to see when we get to the next page, we can go to liters. So we can get to volume. and that's going to be using molarity. Later in the term, we're going to do gas laws, so we'll be able to get to pressure. And then we're going to eventually do balanced chemical equations, and we'll be doing what are called mole-to-mole ratios. So we'll put that here, mole-to-mole ratios. All right, so those are, there's these charts, and you can go everywhere from moles. Chemists are obsessed with them because it's how we do math with the periodic table. It is not what Avogadro set out to do, but it allowed us to suddenly do that. The periodic table was being developed about the same time Avogadro was doing his experiments. All right, so I'm going to go through setting the other ones up. You can follow along. You can try punching it in. So we would start with our, this is our piece of information. So sometimes I try to do that and highlight the bit. Somebody's talking, go ahead.
Somebody had wrote in the chat, how did you get the 386 on number 3?
From this math here. So the formula was 27 carbons. So I have 27 carbons times the 12. Again, the 12, sorry. The 12 is from your periodic table. It's these atomic masses. Then there's 46 hydrogens. And so the atomic mass of hydrogen. So you guys had to have periodic table in front of you, or like Tiffany has a big one she got, and she has it up on the wall in front of her desk where she's learning, which is actually great. Mine's behind me, unfortunately. So usually we're in school where you guys have your nice desks, and I give everybody a periodic table. But we will be using that periodic table. Like, you had to have it for tonight's homework. So just always have it with you. And then there's 1 oxygen. So if there's no subscript, it just means you have 1. You take the number of each element times that atomic mass, and you add them all up, and you'll get 386. Just use 3 sig figs. Let's just go with 3 sig figs, and it will keep it beautifully. So we're going to see that number keep showing up because we're going to do it for the next one. So it's C30H48O3. This is a chemical compound, and you will be given the formula. So same idea of like what the question just was. You have 30 carbons, so you're going to multiply it by the 12.0. Carbon shows up a lot because we're carbon based, so it's a high amount of the compounds that show up here. And hydrogen. When you're doing your homework, though, always double check that you remember them right, but you do eventually just know them. So again, this 12, and this time we have 3 oxygens. These numbers are from the periodic table. I am showing them to 1 decimal place. You can just write it as 12, 1, and 16. But some of the elements you are not going to want to round to a whole number. So staying in that habit. And again, you multiply the number of each element times the atomic mass, and you add them up. Yeah. So that question, I don't know who asked, because that's actually the key question. And it was something I tried to do in the pre-lecture. It is a really common question, and it's really one of the 2 key pieces. So we get 456 this time for the next example. That number you have to get for every question, and it's different for every compound. And then Avogadro's number we'll be using. That's kind of the point of this. The thing is this lecture right now probably seems crazy because it's like she's using these weird words. She's dressed like a mole. What is going on? I feel blinded by this whole thing, like a mole. These end up being one of the easiest things we do because once you get the pattern, they all look very much the same. So yeah, let's keep going. All right. so pick your starting place, write down where you're going, which is molecules. Just don't abbreviate. This one starts with a metric prefix, so I apparently was obsessed with micrograms when I wrote this. First step, get rid of your metric prefix if you have one. So if you're starting with grams or micrograms or milligrams, get rid of that extra piece. So again, back to Shaylee's question, using my chart to be consistent, a microgram is that. You guys all know micrograms now because we just did it. Now we're going to change our grams to moles. That's the key. Go to moles. If you're in doubt for like the whole rest of the term when we're doing math, whenever you're not sure what to do, get to moles, because from moles we go everywhere. There's a reason we're obsessed with them, because they're really handy. All right, that gets us to moles, and now we can get to molecules. And it is the 6.02 times 10 to the 23 molecules per 1 mole. So notice the mole always gets the number, is getting the number 1. This 456 came from the periodic table. And this is Avogadro's number. There is a shorthand for doing it. And when you're using Avogadro's number, you will almost always have an exponent, and it limits us to 3 sig figs. All right. Sometimes my answers, you should be getting the same answer as me. Let's do the last one, and then we have another page we'll walk through together. All right, this one's a little different. Oh, and to know, actually, this was a question I was going to ask. Like in this one up here, we divided by Avogadro's number, but in this one, number 2, we multiplied by it. And then here we divided, and here we multiplied. So how do you know if you're going to multiply or divide? Somebody must know.
You'll let us know in the equation with the times
I
table.
was going to say, is I like see the orange thing flash, and I imagine Brittany's like typing in all capital letters saying, somebody said something. I don't know who said it because your name didn't show up. Say it again.
Christy, you'll let us know with the times table.
Not quite.
Okay.
It has to do.
Units?
It has to do with the units. It's how the units cancel. So if the atoms, if I start you with the atoms, then your first step is going to be to divide by Avogadro's number. Or if I start you with molecules, your first step is going to be to cancel the molecules out. So that means you're going to be dividing by Avogadro's number. Whereas in these other ones, we were solving for atoms or molecules, so we never canceled it out. That's just where we ended with. So it's why we did those. That's why you had that worksheet and crazy worksheet and study set. You guys have all of you have the idea of the pattern. Maybe you don't feel like you've mastered it and you're comfortable, but you are. You all have this idea of the pattern of the units canceling out. All right. So this one is a little bit different, and it's really nice to write down where you're going. I have to learn to write smaller. When I'm in teaching mode, I'm thinking I'm on the board and have lots of space. This one's a little different from the previous one. We went from gold to gold. This was grams of gold. Here we went from silver to silver. Here it was all about cholesterol. Here it was the green tea, the C30H48O3. This one's a little bit different. We are not only, we're changing 2 units. We are changing atoms to milligrams, but we are also, I started you with only hydrogen, and then we're going to end up with this whole chemical compound. So we're going to have an extra step in this one. So now back to the question I asked a moment ago. I'm starting you with atoms. So our first step, the atoms come down and I go to moles. So Avogadro's number always goes with the atoms or molecule unit, and it goes to 1 mole. So there are 2 types of conversions that are going to be going on here. One is getting the atoms to the milligrams, but we also have hydrogen. So I want to label this one better, because I now have to do this extra step, and it's that mole to mole ratio step that I was talking about. You can only change 1 unit at a time. So I changed my atoms to moles. I kept the hydrogen unit there. Now I'm going to keep my mole unit, but I'm going to change my hydrogen to the C15H14O6. So just be careful that you write your compound out correctly. And it's not a 1 and a 1. It is for every 1 mole of the compounds you have. Anybody see how many hydrogens do you have? It's the subscript.
Is it 14?
It is 14. And so that is the number that goes there. So in the mole to mole ratio, it is always a whole number. And now we're at the compound. I got rid of my hydrogen. I cross out my atoms. Now I'm at the compound. I'm going to run out of room. So good lesson for all of us is to start further over and to write smaller. So now we would do our 1 mole to the mass of the whole compound, which is grams. And then something you can do is either you can do a caret, or some students will start down here and start a new line. My grams would come down and I would go to milligrams. That's kind of up to you. I'm going to do a little caret and say the step would be here, that I would have 1 milligram. Back to your question, Shelley, how I do it using the chart, trying to be consistent. I say 1 for the milligram and 10 to the negative 3 for the gram. Lost my calculator. And I'm looking for my calculator because we have to figure out the mass of the C15H14. So you guys can do that while your teacher tries to figure out what I could have done with my calculator, or else so you have 15 carbons, 14 hydrogens, and 6 oxygens. And just a quick comment, it is technically not grams. It is, the periodic table is grams in a mole. So that's why I always label it that way. I don't actually show my work here. I don't need the number. That's why I'm going to scratch paper. Probably why I lost my calculator in the mess that is my room. Somebody can figure out the number and tell all of us. Somebody has a calculator. Do it longhand.
290?
Sure. I'm happy with 290. Thank you. And then we'd punch it in, and I'm pretty sure my numbers are good, but if somebody's doing the math, or all of you should, if you're not doing it right now, make sure you go through. Questions? We got one more page. And that is the mastering moles. No, we got 2 more pages. All right. So I'm going to pause the video. And I'm going to give you guys, you either take a 5-minute break, or again, I did it right. All right, so we're back. Quick question that came up was just a reminder at the end of this last step, I ran out of room. So our milligram, changing our grams to milligrams. So if it wants metric, that's going to be your last step. And then punch these in and the answers were there. So I'm going to go over our next page, which is in my hand, and I'm going to go through it somewhat fast. My recommendation again, I've said many times, is to watch the video, to try all of these on your own. So if you're watching the video, to stop the video and try a problem and then watch me do it, and then stop it and try the next one. And so you want to be able that you can do these. All right, so we're solving for picograms. Question Shaylee asked, well, I had it on pause. This is actually a great time to start you're gonna need a note card or a note piece of paper. And so your metric conversion table, so if you have your periodic table on the wall, that metric conversion table would be a handy thing to have there. All right, 1 billion is 10 to the 9th silver atoms. So you can write it like that, or you can say 1 times 10. If you use the E key, it would be 1E9. Again, it has to do with how you use your calculator, and that's what my office hours, again, I have an office hour Thursday evening or Saturday morning. And Monday, I'm gonna try and be here a little bit early because sometimes people need help with this, and I stay after too. Right. Again, you have a homework set every class because you can see it's broken into little pieces, so you master each piece and then we move on to the next. So this time we're pulling the atoms down and going to mole. So Avogadro's number is going to be in the denominator. Probably missing my chalkboard. All right. I'm not doing a switch. It's staying with silver both at the beginning and end, so I'm not going to have that extra mole to mole step. A reminder, you want to make sure you divide by the whole number. So if you're not getting my exponent, it often has to do with how you're putting Avogadro's number in your calculator. And that would be a question to ask me during an office hour. All right, then we go to grams. And then our last step, we'll change grams to picograms. So 1 picogram over 10 to the negative 12 grams. And silver was 108. And my answer had 4 sig figs. We're going with 3, so it's probably somewhere around 0.179. Since we're rounding to 3 sig figs, it might be like 0.178 and then picograms. All right. The next one, 123 milligrams of caffeine. So the C8H10, or you can write caffeine. And it just wants us to solve for molecules. So this is a question that comes up. We are not going to pull out any one atom from this. We're going to keep it as the whole caffeine. So you do not need to show the compound in any of the steps. It is only when a question like number 4, when I'm asking just for the oxygen, that you'll want to label more carefully the compound. All right, so we have milligrams. First thing is get rid of your milli. So you can say 1 gram divided by 1,000, but I'm just being consistent. When you add it up, please, these are the numbers. If you're not getting my number, again, talk to me. If nobody's getting my number, it's probably me. But caffeine I use enough in problems. I know the 194. All right. This would be Avogadro's number, 6.02 times 10 to the 23 molecules. Again, don't abbreviate the word because it ends up mixing you up for some reason. There is an abbreviation for this expression, and it's a capital N with a little a. Sometimes I'll have one student who likes to use that, and it's usually somebody who's very good at math. The problem is you'd have to recognize to use that as a number. All right, this one's a long one. I'm going to warn you. If you run out of space, just start in the next row again. You wouldn't be the first one. And I have all those zeros. I don't know how many zeros there are because they don't matter, but it's kind of a psychological test because half of you have to count and get the right number of zeros. This is gallons. So 4 quarts to 1 gallon. So another thing that you'd want to put on that note card for the midterm would be those US conversions that are common, like 2 pints in a quart, 4 quarts in a gallon. I went to quarts because we're going to now change our quart to 0.946 liters. So this question is just using the stuff from previous worksheet and combining it with the periodic table. So my gallons, I got to quarts, I got to liters, and now we're going to use that piece of information. So circling all the information in the problem, because you're going to use every bit a piece. To be able to use that, I have to get some milliliters. So 10 to negative 3 liters to 1 milliliter. And again, if you're not able to keep up, remember this is all videotaped. So you can always go back and find that portion of the videotape and say, oh, I want to listen to her do that. You don't have to listen to every part of it. You can just listen if there's one problem that you're not quite sure about. All right, we're at picograms. So picograms to grams. Again, the 1 goes with the prefix. I did want to mention if you did not do well on the mastering metric in that very first lab, go back and do that page again, and you can send me an email of the picture and I can tell you if you got it right. There was somebody who did that today. They had the right idea and there was just something simple they were doing wrong, and we were able to figure it out. It is easier to do it talking during an office hour. All right, that gets us to grams. We want to get to grams because this is all about the periodic table. And so 232 grams to 1 mole. That's the periodic table. That was me adding up the 13 carbons, the 16 hydrogens, the 2 nitrogens, and the 2 oxygens. And again, if you're not getting that number, I did every one of them twice, so I'm pretty sure I didn't do a typo on my thing. Mole is MOL, and this would be our 6.02 times 10 to 23 molecules. I was just making sure I was solving for the right thing, and 2 sig figs because of this step here. Limited us to 2 sig figs. I graded your guys' worksheet today, and again, I added the points from any email bonus points that you've had, and then we'll start over today, and I'll add that to the next one. The most missed thing was sig figs. So again, if you missed a lot of sig figs, please make the time to come to office hours. It's really hard for me as a chemistry teacher to try and explain stuff in email. And so, yeah, I would ask that you do that if you're still not sure. All right. How many oxygen atoms? So this one's going to have an extra step. So I'm going to want to label a little bit more carefully. Right, that one was a long one. That would be like a bonus or something on a worksheet, right? And writing down where I'm going, which is atoms of oxygen. You can write the oxygen before the atoms. That doesn't matter. We're starting at grams. So my first step is the periodic table. Go to moles. And this is one that I do want to label my whole piece carefully. So I have that many grams for that many moles because I'm going to pull out the oxygen in the next step. So this is one where we're changing 2 units. One is we're changing grams to atoms, and one is we're changing aluminum nitrate to just the oxygen. So we're going to have this mole to mole step. So I pull the whole unit down, 1 mole of aluminum nitrate. The next one has a step like this too. And there are actually 9 moles of oxygen. So the parentheses mean to multiply. So we have NO3 and the parentheses is around the NO3. So you have 3 N's and 9 oxygens. So parentheses, you all learned that in math. When you have number in a parentheses, we're multiplying. So that's where that 9 came from. And then 1 mole of oxygen is 6.02 times 10 to the 23rd atoms of oxygen. Make sure your answers have units. You guys have been really good about that. I just graded a thing for my other class, and a lot of people were forgetting units. All right, this is the chromium picolinate, which, right, Pikachu, we'll call it. Right, 43.21 milligrams. Of blah, blah, blah. We want to change our we want to get rid of milli. So we want to get to grams. And then this whole thing weighed 418 grams to 1 mole. And I do want to write my compound. And that is a lot to write. We'll be okay. All right. So in this compound, there is 1 chromium. There are 6 times 3 carbons. So again, that 3, the parentheses, everything in the parentheses multiplies by 3. So there's 18 carbons. There's 12 hydrogens. There's 3 nitrogens. And then there's 6 oxygens. If I did it right, you get 418. All right, so 1 mole of the compound. So a comment. This, I don't know why I did a crazy compound like this. In test situations, I try to pick calmer compounds. It was probably just because it was a cute question, and we're looking for just the hydrogen. So there's 4 times 3, so there's 12 moles of hydrogen. And this is an interesting question. We now want to go to micrograms. So I have to change my mole to grams of hydrogen. So hydrogen is just the 1.01, or you can just say 1. I don't use the 12 again. So I've used the 12 that in this conversion here. Now in this conversion, if I have a hydrogen, every hydrogen is 1.01 grams. There are other ways to do this one, but I'm just trying to be consistent with how I did the other ones. And then 10 to negative 6 grams to 1 microgram, just to be consistent with the chart. So, and I'm going to ask this one is for Brittany, because she's going to have to type it in and then somebody will read it to me. So she gets her bonus. Why didn't I use Avogadro's number in this one? Like, we didn't do the 6.02 times 10 to the 23. She can ponder that. All right, I'm going to move on. You keep pondering it, Brittany. That question was for you. And she can keep thinking about it. I'm going to move on, just in the interest of time. This is the next lab. So lab 3 is about molarity. So this is not on, I don't know if this is on the study set. I'm pretty sure it's not, but it deals with moles. And it is, a symbol is capital M, and it means moles per liter. And when is it used? It is used, sorry, I was thinking about something. It's used in lab. It's used for concentration.
Brittany says because we did not start with atoms and it did not ask for molecules.
She got it. Yeah, so for all of you, back to that one, it started with grams, it started with milligrams and went to micrograms. It didn't ask about atoms or molecules. And so that's why I have that problem on there. If the question doesn't start you with atoms or molecules and it doesn't ask for atoms or molecules, there's no need for Avogadro's number. So grams is all about the periodic table. And so, yes. All right. Awesome. Thank you, Brittany. Hooray. All right. If there's anybody else who can't like ever answer because they don't have a capacity of video, you can let me know if you're wanting to answer. And you should care because in lab we work with concentrations and everything's labeled as molarity. This is like one of the big uses of chemists with moles. So lab 3 that you would normally do in lab would use this. And I actually did the lab and videotaped myself doing the lab. I think it's like a 20-minute video. So this is not this week's lab. This will be next week's lab. There'll be a video link that the lab will have. And you watch it and you do the math along with me and then you answer the questions. And you can decide if I did okay. So let's just do a couple of these practice and all right. So there's our mass of bleach and there's our volume. So molarity, what we're trying to find is the molarity. We're trying to solve for moles per liter. We're trying to solve for 2 units, which means you have to start with 2 units. So you're going to start with grams over the milliliters. The grams we can change to moles because we just learned the magic periodic table, and milliliters we can change to liters. So we just had to put our numbers in, 23.456 grams. All right. That comment I made, if I'm asking you to solve for 2 units, molarity is 2 units, like density is 2 units. Density is a mass over a volume. You have to start with 2 units. That's why that hints of if you have 2 pieces of information, like on the next one, we have 850 milliliters and we have molarity. That big M means moles per liter. So you would always start with the other piece of information. So this is the bleach, so NaOCl, and we would change our grams to moles. Again, this step is the periodic table. So you just add up. So I wanted to do this page because it brought in chlorine, and it was something we were doing carbon, nitrogen, oxygen, hydrogen for all those other problems. Even like sodium just rounded to 23. It says 22.99. But if you had something like magnesium, I would keep it as 24.3 because that 0.3 can make a big enough difference. So I'm looking for other ones like nickel, I would do 58.7. So unless it's like sodium right on there, or like oxygen is 16.0. So chlorine, I do use it as 35.5 because it's in between 35 and 36. So you do want to show 3 sig figs there. All right, and then that gets rid of my grams, milliliters to liters. So again, back to Shaylee's question from before, really important. How you do metric, just be consistent, how you make sense to you. So if you like to do 1,000 milliliters to a liter, great. I'm trying to be consistent and just use the chart. So again, the chart is 1 milliliter is this many liters, and we should get that answer up there. These answers here are a courtesy to you. I'm pretty sure they're right, but I know I had one wrong. I think it was in my other class. I don't remember it was you guys. I mean, keep going. Again, go back. This This is not on the study set, I'm pretty sure. But if it is, then you can come back to this page. But it is in the lab, and so it would be something that you'd be responsible for the midterm. So the first 3 labs, which is 3 totally different labs. Working with molarity, you want to get to liters. And then the molarity comes in. So underline or circle or highlight all the information. You're going to use the information I give you. So like the bonus on the previous worksheet, I think there were 6 different pieces of information, and most of you got it, and that was awesome. So 0.015, and instead of writing a big M, change it to moles per liter. That's the biggest piece of information here. All right, this is KBR. We're solving for grams of KBR. So we just have one more step, moles to grams. And if from this lecture, you're going, I'm totally lost. She's doing this, she's going so fast. And I know like all of you are thinking that. It's late, we're getting tired. Tomorrow is Hydrogen Day. It's really exciting. You'll get an email about that. If the only thing you got from this lecture is you're like, well, I at least kind of think I have a better idea of what those numbers like the 40.08 for the calcium is. So for the KBR, that you could add up the K and the BR and get around 119. So for those, yeah, so the bromine 79.9 and the K is 39.1, and there's just one of each. So you add them up. And 2 sig figs, because the information I give you, whichever has the least, so we can only have 2 sig figs. All right, so we get up there, my answer. All right, so again, 2 pieces of information. Underline your information. Take a deep breath. Do not just start with the first piece of information. Underline it, say, okay, I'm going for milliliters. And start with the one that has only 1 unit, because we're solving for 1 unit, and that would be the grams. 5.55 grams. If you want, you can write the K3PO4. You don't have to, because I don't ask you to pull out any one type of atom in there. All right. So we're dealing with molarity. It means we're dealing with moles. This whole lecture is about change your grams to moles. Again, I'm not labeling as well as I was, because I'm not pulling out a single type of element. This comes out around 212. I went ahead and kept the 0.3. So again, for something like carbon, I just do it as 12, 12.01, that's 12. Same with nitrogen, but for boron, I would do 10.8. All right. And then the molarity comes in. So back to the question I'd asked Brittany, on this page, we're not going to use Avogadro's number at all. There's no need to use Avogadro's number because there's no mention about atoms or molecules. None of these questions say how many molecules or how many atoms. So we're using molarity here instead to change to volume. And I flipped the molarity upside down. So this is similar like when we did density. It is always per 1 liter. And so the 1.618 stays with the moles. And then I just need to get some milliliters. So 10 to negative 3 liters, it's 1 milliliter. Punch it in. So how the units work out tells you if you have to flip it upside down or not. this becomes a really nice tool. And the reason we did the factor label is it's a really handy tool in chemistry using the periodic table and molarity, and something we get to in a couple weeks. All right, 2 more. And there's my information. This is what I want to find is grams of sodium sulfate. So I like to write down where I'm going. And I'm starting with 300. I want to start with the 1 unit. So again, the big M is 2 units. You can actually even cross it out and write above it moles per liter if that's how your brain thinks. If that helps your brain think, I should say. All right, we're dealing with molarity, so you got to get to liters. So milli is 10 to negative 3. And I know I'm going fast again, but you can always go back in the video and watch a step. You can just sit back. I had a student my first year who would just sit there and stare at me the whole class. He sat in the back middle, and I was like, kind of creeped me out because I was much younger. He ended up being one of the best students I've ever had. He was just brilliant, and he would just sit there and listen. And I'm not a good listener, and so I've realized this environment has been actually very good for me because I have to learn how to listen, because that's what my life has become. All right, liters to moles, because this page is about molarity. If you see the big M, and it is not moles of sodium sulfate, it is just the sodium. All right, I kept it right side up because that's how the liters canceled. So it's always per 1 liter. And now I'm at moles of sodium. I want to switch to sodium sulfate. And it is the mole to mole step that you do that. So I pull down the mole of sodium, and now I can switch to the compound, to the sodium sulfate. Now, this one, I did this question like this on purpose. The 1 goes with the compound. So it's not that the 1 always goes in the denominator. The 1 is with the compound, and in the compound, there are 2 sodiums. That's what the subscript means. There's 1 sulfur. The 4 is after the oxygen. So 2 sodiums, 1 sulfur, 4 oxygens. And now 1 mole of the compound, the sodium sulfate, is 142 grams, and we should get that answer up there. All right. Once you can do like this page, these last 2 pages are really given to you. These, you don't turn these in, these are for you. I would tell you to do them again. And you can do them with the video, but stop the video and try the problem and then watch me do it. If you're really stuck, but try it, because you're gonna find that even though you say you're stuck, try it and see if you really work, because we actually do remember sometimes things better. Or watch it more than once, and then you'll have it. All right. So the next question is a dilution question, because there's one of these in the lab. And so you want sugar. I didn't give you the formula for sugar because it turns out we don't need it for this. The dilution formula is M1V1 equals M2V2. And when I first started teaching, I used this formula. I taught it because you use it a lot in lab, not in college chemistry, but when you go on. And then I didn't really teach it, but it's really helpful for us because when we get to gas laws, we're going to see formulas like this. So here I wrote it as 1s and 2s. In the lab, I wrote it as initial and final. So that it doesn't matter. Again, whichever your brain wraps around better. These 2 numbers are going to go together. the 555 milliliters and the 0.123 molar. And so rather than making it up from scratch, which was what was going on here, so in the lab, I have to like measure out the mass and add how much water to dilute it. I'm just going to have a solution that's already made up, and I'm going to dilute it. So these are technically our final, what I want. It doesn't matter if you put these as the 1 or 2, but the molarity is 0.123 molar. And my volume is 555 milliliters. The original molarity that the gnome hands me is 3.33 molar, and I want to figure out the volume. So this is my unknown. This is my question mark. So it's just my volume. So it's algebra. We just rearrange. Divide by the 3.33. So the wonderful thing of you all muted is nobody could say, but you didn't change the milliliters to liters. In a dilution problem, you actually don't have to. The molarity cancels, and the unit I'll be left with is milliliters, which is what I wanted. So since it's not, this is not factor label, you just plug in the units and you're left with whatever you have. All right, so no use of the periodic table on that one because it didn't ask about grams. We didn't have to use Avogadro's number. It's again the question I'd asked earlier. There was no question about molecules or atoms. It's just specifically a dilution problem, and I do one of these in the lab. You kind of do it along with me watching. And so next week's lab is just math. You watch the short video and do a bunch of math with me. All right. Questions?
When do you normally post the homework for like this weekend, like the homework for tonight's lecture? When is that usually posted by? Because I looked forward earlier to print it out and I didn't see it yet.
Oh no, I learned my lesson. Not until after I go through the lecture, so it should show up tomorrow morning. So if you, for those of you who want to work on it on the weekend, you have a worksheet due tonight, you have a lab due Saturday, so we want to get that stuff in. So it will show up, and then the other stuff will be in the folder hopefully by will be there by Sunday. So next week's lecture and everything. All right, and it will be next week. It will show up as a week 3 folder. Who I think Shaylee just asked that.